Alright, so we're doing exercise 5C, and in this video I'm going to answer question 2b, which is asking us to sketch the graph of each of the following relations, then state the range of each, and specify whether the relation is a function or not. So here in B, we've been given x squared plus y squared equals 4, and my domain is restricted between 0 and 2. The very first thing we're going to notice is that this is a circle. And we should also be able to recognize some properties about this circle. First of which is that its center will be at 0, 0. And we should also be able to recognize that the radius is going to be 2. And with these pieces of information, we can now come to our graph and give it a sketch. So its center will be here at 0, 0. And because of the radius is 2, it's going to go up 2. It's going to go down 2, it's going to go to the right 2, and it's going to go to the left 2. Now that I have my center and intersection points marked down, I can give it a graph. So it's going to look like this and like this. But we haven't taken into the account the fact that my domain is restricted. So that means my domain is going to be 0 to 2. So therefore, when it comes to my graph is only going to exist between x equals 0 and x equals 2. So that means this left hand side of my circle will not exist. It's going to go away. That leaves me with a semicircle of just the right hand side. So this is what my graph is going to look like. So it's ever so important that you take into account your domain. Now that we've done that, let's figure out what my range will be. My range is all my y values. And as you can see, it starts at y equals -2 and it ends at y equals 2. So here I can put in -2 to 2. Next, so now that I've found my domain and range, I've given it a sketch. I now need to figure out whether or not this is a function. And to do that, I'm going to be using the vertical line test. In the textbook we read, if a vertical line can be drawn anywhere on the graph and it only ever intersects the graph a maximum of once, then the relation is a function. So what I'm going to do is I'm going to get a straight line, and I could do this anywhere on my graph. And as you can clearly see, this vertical line crosses my graph twice. So if I get a pen, you can clearly see it crosses there and it crosses there. So this means that this is not going to be a function. So here I can write no. This is not a function because it crosses it twice. Now, if we wanted some explanation as to why this is the case, we could go to our definition of a function, which is a function is a relation such that for each x value, there is only one corresponding y value. So there is only one corresponding y value. But if we come and we look here, we can clearly see that I'm going to have, for x equals 1, I'm going to have a y value here, and I'm going to have a y value here. So that's the reason why it isn't going to work. Now, if we just wanted to do a little bit more work on this question, we could actually figure out what these 2 points are, which would definitively prove it. Well, the vertical line definitively proves it, but let's just do a bit more work. So we could say, let x equal 1. So now that I have this, it would be y squared plus 1 squared plus y squared equals 4. 1 squared is 1 plus y squared equals 4. I'll minus 1 from both sides. I will then square root both sides. So I'll be left with y equals plus or minus the square root of 3. And as you can see here, because I have this plus or minus, I've gotten 2 solutions out. So one solution will be 1 square root of 3, and my other one will be 1 minus square root of 3. And this one would be here and one would be here. So this would be 1 square root of 3, and this would be 1 minus square root of 3. So as you can see, for one x value, I have more than one corresponding y value, and that's why this isn't a function. Hopefully this explained everything in question 2b, and it has helped you. I'll see you in the next question.